Students, in today's lecture we are going to solve some of the problems from trigonometric chapter. This is for 10th class SSC, and expected problems we are going to solve from the trigonometric chapter. Okay, so first problem, we'll start here without wasting any time. Given a right angle triangle PQR, and they have mentioned the angle Q is 90 degrees, that is, it is right angle at angle Q, and they have given the length PQ is equal to 7 centimeters, PR equal to 25 centimeters, and they are asking to find tan P minus tan R. Okay, and here if you see the angle P, opposite to the angle P, it is nothing but QR, and adjacent to the angle P, it is nothing but PQ. Okay, so tan P is, we can have it as QR by PQ, and PQ we know the length, that is 7 centimeters, but we don't know what is RQ. They have given the hypotenuse length, that is PR, it is given, that is 25 centimeters, and we know the Pythagoras theorem. Using the Pythagoras theorem, we can calculate the unknown length, that is QR. So from Pythagoras theorem we know that the hypotenuse length square, that is PR square, is equal to sum of the other two length, that is square of the sum of the other two lengths, that is PQ square and QR square. So here PR, that is given hypotenuse, it is 25, so we have 25 square, and PQ it is given 7 square here we get, and we need to calculate what is QR. Okay, 25 square we know that it is 625. These are the sum of the squares which you have to memorize. 7 square we know that in 7 table we get 7 into 7 49. Now we want to calculate QR, so we are going to take this 49 from right hand side to left hand side, and it becomes minus when it comes to the left hand side. So we get 625 minus 49, that is equal to QR square. What is 625 minus 49? Just think very fast. So it is nothing but 576 is equal to QR square. Now what we want here is to calculate QR, and we know that QR, if you take, we take square root on the left hand side, that is square root of 576. This is also one of the important square root, that is 24, that is 24 square. You can, if you want another step, we can add here, that is 24 square is nothing but 576. This square and square root will get cancelled, and we get it as 24. So QR is 24 centimeters. Okay, so we got opposite side to P, that is here we got it as 24 centimeters. So from this we can calculate tan P. Tan P here it is nothing but 24 divided by PQ 7. So tan P we get it as 7 by 24. Okay, QR is the opposite side and PQ is the, here we get tan P is equal to opposite side QR 24 divided by adjacent, that is equal to 7. Okay, opposite is 24 to P, QR divided by PQ, QR divided by PQ. So what is QR? We got 24 divided by, that is PQ is 7. So this is tan P. Okay, and they're asking to find tan P minus tan R, so we have to calculate tan R. Tan R is equal to, so when we look at the angle R, opposite to angle R here is, we have, you can see opposite to angle R we have is PQ, and adjacent to we have QR is adjacent to angle R. So we get opposite to angle R is PQ and adjacent to angle R is QR. So we get tan R is equal to PQ by QR. tan r is equal to PQ by QR. So that is going to be 7 by 24. 7 by 24. And what they've asked here, it is tan P minus tan R. So tan P, what we have, 24 by 7. Tan R is nothing but 7 by 24. So if you take the LCM here, we get 7 into 24 is the LCM. Now when we take the LCM for this, it is 7 into 24 by 7, 7 will get cancelled. We left with 24. 24 into 24, we get it as 24 square. Minus, now again 7 into 24 in the denominator divided by this 24. Okay, so this 24 and denominator 24 of the LCM will get cancelled. What is left is this 7 and this 7. So we get 7 into 7, 7 square. Okay, so here what we got is 24 square, that is, we know 24 square is 576 minus 7 square is 49 divided by 7 into 24. So you can just subtract what we get, 576 minus 49. Can anybody guess? Just do it, no guessing here. 576 minus 49. 500 and, if you want you can do the subtraction. 576 minus 49, 16 minus 9, that is 7. You have taken a carry, so here we have 6. 6 minus 4, 2, and 5 will be left, so we get 527 divided by 7 into 24, we get it as 168. So this is the final answer, that is tan P minus tan R. Okay, this is one of the expected question which can be present in S7 or similar to this. Another question we are going to solve, that is, suppose they given sin A. Okay, sin A is given 24 by 25, or I'm just taking all the possibilities. Sin A can be given 12 by 13. Okay, 12 by 13. This they can give, this they can give R. They can give cos A is 12 by 13, and they can ask other ratios need to find. Okay, so here any one we take. So for now we can going to take sin A is 24 by 5, and they're asked, for example, they ask to find what is cos A, what is tan A, what is secant A, what is cosecant A, and what is cot A. All these are the ratios, right? So what they have given is sin A 24 by 25 here. So first you take the right angle triangle, and we can take it as ABC, and here we have angle A. Okay, and they have given opposite side 24 divided by hypotenuse. Sin A, what they have given is, sin A is 24 by 25, length of opposite side divided by the hypotenuse. So 24 divided by 25, we can write hypotenuse is AC, and opposite to angle A is 24. It can be centimeters or any units. Okay, and they're asking to find, for example, what is cos A, you find what is cos A. So to calculate cos A, what we required is adjacent side length. Okay, adjacent side length we need to have, that is AB. We need to calculate AB value. Okay, so that we can do using the Pythagoras theorem. Here we need to use Pythagoras. Using the Pythagoras theorem, we can calculate AB, so that we know that hypotenuse square, that is AC square, is equal to AB square, which we need to calculate, plus BC square. Okay, BC square, it is given 24 already. It is similar calculation to what we have done in the earlier problem. Okay, so in place of this, even they can give 12 by 13 something. So BC square, it is nothing but what it is BC given? 24 square. Okay, so 625 minus 24 square is how much? 576 is equal to AB square. So 625 minus 576, it is nothing but 49. That is equal to AB square. So from this we get AB is equal to 7. As we know that is 49, we can write 7 square. Both the side squares will get cancelled and we get AB is equal to 7. Okay. So we got adjacent side length AB is equal to 7 centimeters. So from this we can calculate easily what is cos A. Cos A is nothing but length of the adjacent side 7 divided by the hypotenuse 25. Okay. Now suppose you want to calculate what is secant A, reciprocal of cos, that is 1 by cos A, that is 1 by 7 by 25. If it reciprocal we get 25 by 7. Right. This is our secant A. Suppose we want to calculate what is cosecant A. Cosecant A, we know that 1 by sine A, and what they have given sine A already 24 by 25. 24 by 25 it is given. So when it reciprocal we get it as 25 by 24. This is cosecant A. Another one, even they can ask what is tan A. Tan A directly by looking at the triangle itself we can find. Even secant A, cosecant A also we can directly look at the triangle and we can find. Secant A is nothing but reciprocal of cos. Secant A is hypotenuse by adjacent side. So you will get confused. So instead of by looking at the diagram, you can calculate secant A, but don't do that. First calculate cos A, reciprocal cos A, 1 by cos A secant A. That will be easy to solve in the exam. Okay. Now tan A we want. Tan A is nothing but this, you have remember already, tan A is length of the opposite side divided by length of the adjacent side. So length of the opposite side is 24, adjacent side length is 7. Okay, so 24 by 7, this is tan A. And what is cot A? Can anybody tell? Cot A is 1 by tan A. So that is nothing but 1 by 24 by 7. That gives us, when it goes into numerator, 7 by 24. So like this, any combination they can ask. Okay. Another problem we'll solve for today's in this lecture, and then we conclude for today. Okay. Another problem they can ask, that is in a right angle triangle ABC. ABC is a right angle triangle you can say, or a right triangle also you can say, right angle triangle, and they'll give 90 degrees is at angle B, 90 degrees at angle B. Okay, or they can mention instead of giving angle B, right angle at angle B. Okay, right angle at angle B. This also they can mention. Mean written part, right angle at angle B or angle B equal to 90 degrees, both are same. Okay, if they can give tan A is equal to root 3, tan A equal to root 3, then find what is sin A cos C. See here, it is little typical, cos A into sin C. This is what they're asking to find. Okay, so I think it is clear. Angle B is 90 degrees and they have given tan of the angle A as root 3. So first we'll draw the triangle here, right angle triangle. With angle B they have mentioned it as 90 degrees. Okay, remaining two coordinates we can take it as A, B and C. Easily you can take it as Now what they have given in the problem is tan A is root 3. Okay, tan A is this angle, and they have given tan A is equal to root 3. Okay, now by definition of tan, what is the ratios we get? Length of the opposite side divided by the length of the adjacent side. So that is BC by AB. But what is the problem here? If you take like this, since they have not given any of the length of the sides of the triangle, but then how to do? That is the typical case, that you have to remember some of the values like this. That is, we know that, or you have to memorize tan 60. Tan 60 is root 3. This is very important. If you go with the ratios, they have not given any side length. So if you use BC by AB, what is BC? We don't know. What is AB? We don't know. What is hypotenuse? We don't know. But you have to solve. But you have to remember these values, like tan 60 is root 3 and tan 30 is 1 by root 3. Okay, these some of the values. Like this we have sine 30, sine 60. We'll see in the next coming classes about these degree values also. So tan 60 is root 3. That means angle A is nothing but angle tan A is equal to root 3. That means tan 60 is root 3, which we have seen. So if you compare these two here, so this angle A is going to be 60 degrees. So angle A here it is 60 degrees. Okay. So angle A we know that it has 60 degrees. What they're asking, what is sine A, what is cos C, plus what is cos A, multiplication here into sine C. Okay. So we got the angle A as 60 degrees. Okay. This is 60. Now can anybody tell what is the angle C? In the first lecture which I have taken, lecture 1, like basics, lecture 1, we have discussed this, that sum of the angles of a triangle, that is A plus B plus C, is 180 degrees. This is very basic, which you have to remember. Okay, so we know here the angle it is 60 degrees is A and B is 90 degrees, plus C is equal to 180 degrees. So can anybody tell what is the angle C here? 60 plus 90, 150. Okay, 150 plus C is equal to 180. I'm going to write here 150 degrees plus C is equal to 180 degrees. So C we need to calculate. So we take this 150 on the right hand side. So 180 minus 150. So what is the value here? 180 minus 150, 30 degrees. So C value we got it as 30, and A angle there we got it as 60 degrees. So what is the question they asked to find? That I'm going to write again here. What they've asked to find? Sine A, cos C. Every time you should not get tensed if they ask little small changes in this. What is important is you should be very careful and calm when you solve this problem. No tension. Don't get any side of tension when you start doing problem. Do something which you know. You get some marks instead of leaving it. Okay. Sine A we know, sine 60. Okay, and cos C it is nothing but cos 30, plus cos A it is nothing but cos 60, into sin C it is nothing but sin 30. So here these values which you have to remember is sin 60 it is root 3 by 2. This value you have to memorize. Cos 30 also root 3 by 2. I will give a trick here. Cos 60 it is 1 by 2. Sin 30 it is 1 by 2. So how you going to remember it is, if it is better you buttify the values by heart. So here you can see this is 60, it is 30. Sum is how much? 90. So the sin 60 and sine 30 are going to be same values. Similarly, cos 60 and this is sine 30. What is the sum of 60 plus 30? 90. So cos 60 is same as sine 30. Similarly, okay, we'll see that this value will solve first. Root 3 into root 3 by 2, that is root 3 square. 2 times we have 2 square. 1 by 2 into 1 by 2 we get it as 1 by 4. And we know the square and root will get cancelled. So we get here 3 by 4, 2 square in the denominator here, plus 1 by 4. This simple LCM we take 4 and here 3 plus 1. So that is 3 plus 1 is 4. 4 by 4, remember it is 1. Some students say it is 0. By confusion it is not 0, it is 1. 4 divided by 4, it is 1. So what they have asked, we got the answer, it is equal to 1. Okay. So as I said here, 60 plus 30, 90. So sin 60 is cos 30 same. Cos 60, sin 30. 60 plus 30, 90, they are same. Similarly, we have sin 45 is equal to cos 45. Because sum of these two is how much? 45 plus 45, 90 degrees. Okay. Like this you can remember. And even we have other values, that is sin 0 is equal to cos 90, because 0 plus 90, it is 90 degrees, these two are same, it is equal to 0, and this is equal to 1 by root 2. Another last value I'll write and we'll start for today, that is sin 90 is equal to cos 0, that is 90 plus 0, it is 90, both are same, that is equal to 1. Okay, I think it is clear. Some more problems we're going to solve next classes. Thank you. Please share and subscribe. Thank you very much. Friends, this is lecture number 3 for trigonometry, which we have started. Okay, in today's class we are going to see about relations between trigonometric ratios, and then one example problem we'll try to solve. Okay, now first we'll see the relation between trigonometric ratios. We have already seen in the previous class what are the trigonometric ratios. Now we'll see the relation between these trigonometric ratios. Okay, we have sin theta, cos theta, tan theta we have seen, and reciprocal of sin theta is 1 by cosecant theta. Okay, and we know that sin theta is nothing but length of opposite side divided by length of hypotenuse, and cosecant theta is reciprocal of this, that is length of hypotenuse divided by the length of opposite side in a right triangle. Okay, this is angle theta ABC. Okay, AC is the hypotenuse, the length of the hypotenuse L. Opposite to angle theta is BC. So length of the BC you can take it as some K, and adjacent side length you can take it as M. Okay, now if you multiply these two, that is sin theta into cosecant theta, we get it as, because sin theta, cosecant theta is 1 by sin theta. So this sin theta in the denominator and the numerator will get cancelled, we get it as 1. So this is one of the relation which gives sin theta into cosecant theta is equal to 1. One relation we have, that is sin theta into cosecant theta equal to 1. Similarly, we have another relation, that is cos theta is 1 by secant theta, and we know the definition of cosine theta or cos theta, that is length of adjacent side divided by the hypotenuse, and secant theta is reciprocal of this cos theta, that is length of hypotenuse divided by length of the adjacent side. So if you multiply these two, that is cos theta into secant theta, if you multiply, So we have adjacent side length divided by hypotenuse length into hypotenuse length divided by adjacent length. So here this hypotenuse from numerator denominator will get cancelled, and the adjacent length and the denominator adjacent length will get cancelled. We get it as 1. So the cos theta into secant theta, we get it is equal to 1. This is equation, the relation, and second relation we can have. Now another relation we can have is between tan theta and cot theta. We know that cot theta is nothing but reciprocal of tan theta. Tan theta into cot theta is 1 by tan theta. So these two will get cancelled and we get it as 1. So this gives the relation between cot and tan. When we multiply cot into tan, we get it as 1. Right. These are the three relations which we can have between the trigonometric ratios. Now we'll see one example problem. One example problem we have seen already in the previous lecture. Another example problem we are going to solve now. That is, if they give the relation between sine and sine of an angle. So we get here the problem, it is sine of an angle, it is given. Sorry for the disturbance. Example problem here we have, they have given sine A, small a it can be, or capital A, or it can be theta, anything, it is an angle. Sine A it is given, we know the sine is nothing but opposite side length divided by the hypotenuse. The given is sine A, and they are asking to find, given sine A, and they are asking to find other trigonometric ratios. Other trigonometric ratios they are asking with respect to angle A. Okay, find other trigonometric ratios of angle A. So we can take it as small a, or you can take it as capital A, or it can be theta. It is all same. So they have given, what is given here, first you write, given is sine A is 3 by 6. So from sine definition we have opposite side length divided by hypotenuse length. So if you draw a triangle here by taking angle A here, this is ABC, this you can take it as angle A or theta we can take. Opposite to angle A we have is BC, hypotenuse here is AC. Okay, so the length of the BC here is 3, it can be 3 centimeters, you can write it as 3 centimeters, and length of the hypotenuse we have it as 6 centimeters. And to find other trigonometric ratios like cos A, we want to find, we need to have the length of the adjacent side divided by hypotenuse, length of the hypotenuse. So we need to find here adjacent to the angle theta, the angle A is nothing but AB. AB is adjacent to angle theta. So we have to find the angle, we have to find the AB length. For that we use the Pythagoras theorem. Pythagoras theorem is used. Using Pythagoras theorem, we can find the adjacent side length. So we know that hypotenuse square is equal to opposite side square plus adjacent side square. That is lengths. All these AC, AB, BC are nothing but lengths. And hypotenuse it is given 6 square. Okay, and opposite side it is AB, it is given, opposite side is BC, BC length it is given. Okay, and we need to find AB square. BC it is given 3 square. Okay, so 6 square it is 36, AB square, and 3 square it is nothing but 9. Now we bring this 9 on the left hand side, we get it as 36 minus 9 is equal to AB square. We know 36 minus 9, it is nothing but how much we get? 36 minus 9, it is 27. So we get it as AB square is equal to 27. Okay. So we get here AB is equal to root 27. Root 27. So this is the adjacent side length. Okay. 36 minus 9, we get it as 27. Right. Now we want to find the cos theta. Cos theta is nothing but length of the adjacent side AB divided by length of the hypotenuse, that is AC. So it is nothing but root 27 divided by 6. Here we can have, even we can simplify this root 27 as root 27, we can write it as 9 into 3 divided by 6. So we can take it as root 9 into root 3 divided by 6. We know that root 9 is nothing but 3 into root 3 divided by 2 into 3. 3 into 2, it is nothing but 6. So numerator 3 and denominator 3 will get cancelled, and we get it as root 3 by 2. So this is nothing but the ratio of adjacent side length divided by hypotenuse, root 3 by 2. Right. Similarly, we want to find what is tan theta. Tan theta is nothing but opposite side length divided by adjacent side length. Opposite side length is nothing but, which already given, it is 3 centimeters, and divided by adjacent side length, it is root 3 by 2. You can write it as centimeters here, root 3 by 2 centimeters. Overall this ratio, this centimeters will get cancelled. So this 2 goes into the numerator, we get it as 6 by root 3. And we should not keep any time root in the denominator. So we do the rationalizing here. 6 root 3 divided by root 3 into root 3 square. So this square root will get cancelled. We get 6 root 3 divided by 3, and here we get 3 2s are 6, we get 2 root 3. This is going to be tan theta. Similarly, if you want cot theta is nothing but reciprocal of the tan, that is 1 by 2 root 3. And if you want to find secant theta, how are you going to find secant theta? Secant theta I am writing here. Secant theta is nothing but reciprocal of cos, that is 2 by root 3. And if you want to find cosecant theta is nothing but reciprocal of the given sign, that is cosecant A. Cosecant A here we have, that is opposite of sign, that is 6 by 3, that is going to be 2. So that is cosecant A. So here cos theta I have written, it is cos A, and secant A, theta A you can take tan A. Okay. So this is cot A. Theta can take is, that is basically when we take a right angle triangle, here we can take it as theta. This is A, B, C coordinates. You can write it as angle BAC is nothing but the angle of A, that you can write even as theta also. Okay. Thank you for much watching. Please share and subscribe. Thank you. Students, this is, we have started a lecture series. This is lecture number 4 in the trigonometric of SSC mathematics. In this lecture 4, we are going to solve one example problem and one from the exercise 11.1 in the trigonometric chapter. First we will solve the example problem. Example we are going to solve. Okay, I will write first the problem what they have asked. They have given, consider a triangle PQR, right angle right angled at R, in which they have given the lengths PQ is equal to 29 units. They have given units are centimeters, millimeters, you can take, and QR it is given 21 units, it can be centimeters, and they have given that angle PQR is equal to theta. Then they are asking, then find the values, of, they've asked to here cos square theta plus sin square theta. Another problem of this question is cos square theta minus sin square theta. So we get a special case in this when we solve it, then you can understand. Okay, so we have to find cos theta and sin theta, and what they have given the problem, the right angle is at angle R, that is 90 degrees, and they have given the PQ and QR lengths. And first we'll draw the right angle triangle, and they have mentioned the problem that the right angle is at R 90 degrees, and we can take now PQR. Now PQ is going to be the hypotenuse. They have given it as 29 units. You can take units or you can just write 29 also, because when we go for ratios the units will get cancelled. And they have given QR also, that is 21 units. QR is 21 units, it is given. And they have given angle PQR. PQR is theta. This is angle theta, which they have mentioned. This you can take, here they have not asked, it can be theta 1, but they didn't ask according for this angle. What they have asked is angle theta is at angle Q. I'll write here angle PQR, they are saying to consider it as theta. Okay, the central alphabet of this PQR is the angle which they have mentioned, that is theta, you have to take. Now we have to find cos theta and sin theta to evaluate this cos square theta plus sin square theta and cos square theta minus sin square theta. Okay, so we know that sin theta is the ratio of opposite side length divided by the length of the hypotenuse. Opposite to theta here is nothing but PR. So we have to find PR, which is not given. So that is length of PR is L divided by the hypotenuse length, that is 29 units. L is also you can consider as units. So we can L units divided by 29 units. Units will get cancelled. It can be centimeters, it can be millimeters, it will get cancelled. So to calculate sin theta we need to have the length L, that is length of PR, we have to calculate. So how to calculate the length of PR? Can anybody guess? We have already seen the previous lecture that we have to use a theorem called, what it is? Pythagoras theorem. We have to use Pythagoras theorem is used here to find the length of PR. So we are going to write using Pythagoras theorem, which states that again PQ square, that is length square of the length of the hypotenuse, is equal to square of the length of adjacent side plus square of the length of opposite side. So here opposite to theta is PR, so and the adjacent side here is QR. So the lengths, PQ is length of the hypotenuse, PR is the length of the opposite side to the angle theta, QR is the length of the adjacent side to the angle theta. Right. So what they have given, PQ is given 29 square. You leave about the units and we have PR square, it is given, we have taken it as L square, and QR it is 21 square. Okay, now what we have to find is L square. We need to find 29 square, it is nothing but 841. Okay, 29 square is 841 is equal to L square plus 21 square is 441. Now same way as we have done in lecture 3 earlier, we are going to bring this 441 on the left hand side. So we get 841 minus 441, that is equal to L square. Now what is L square is equal to 841 minus 441, it is equal to 400. From this we get L is equal to root 400. We have root 400, it is nothing but 20 units. You can write it as 20 units. Here we get, right. So we got the length of the opposite side to the angle theta. Now what we have to find is sin theta and cos theta, and we already have the hypotenuse length, that is 29, and we have the definition of sin theta. Length of the opposite side to angle theta is 20 units divided by the length of the hypotenuse, that is 29 units. Numerator denominator will get cancelled. So this is sin theta, and we know that cos theta is nothing but, in the denominator you remember always for sin theta and cos theta, denominator is same, that is hypotenuse, and numerator of cos theta is nothing but adjacent to angle theta. Here we have, it is nothing but QR. QR is the adjacent side to the angle theta, that is 21. So here cos theta is nothing but 21 by 29. And they ask the first question here is cos square theta plus sin square theta, they are asking to find. So what we do here, 20 by 29 square plus 21 divided by 29 square. This is what we get, and we can take the LCM here. LCM we get it as 841. 841, which is nothing but 29 square. So we get LCM is 29 square, because in the both the terms we have denominator is 29 square. Now for the first term we have in the denominator is 29 square, 29 square, 29 square will get cancelled, and we get it as 1 into 20 square. Same way for the second term also, 29 square in the denominator of this, and this will get cancelled, and we get 1 into 21 square. So we know that 20 square is nothing but 400 plus 21 square is 441 divided by 29 square is nothing but 841. So numerator is 841, 400 plus 441 divided by 841, both will get cancelled, and we get the ratio as 1. So what here we can conclude is, always for any angle theta, sin square theta plus cos square theta is going to be 1. This is very important identity which can be used in solving the problems. Sin square theta plus cos square theta is equal to 1. The second question asked in the problem is, they are asking to find what is cos square theta minus sin square theta. We know the ratios already, you need to just substitute and simplify the things. Cos theta we have already 21 by 29 square minus sin theta is 20 by 29 square. As usual, it is LCM is how much? 29 square. And here we get 21 square minus 20 square. Okay, so 21 square is nothing but 441. 20 square is 400 divided by 29 square is 841. So we get it as 441 minus 400, that is 41 by 841. So this is the answer we get for cos square theta minus sin square theta, right? We'll solve another problem, that is from exercise 11.1. We'll solve problem number 1 in this. That is, they have given a right angle triangle ABC. ABC is a right angle triangle, and they have given the lengths of all the sides, and they are asking to find the sin A, cos A, tan A. Okay, they have given all the three side lengths. Okay, so you can take it as A, B, C. Okay, they have mentioned it as a right angle triangle, and they have given the diagram here. The right angle is at angle B, 90 degrees, and they have given all the lengths. AC it is given 17 centimeters, and here BC it is given 15 centimeters, and AB it is given as 8 centimeters. This is given. Okay, these are given lengths. What they are asking simply is to find sin A. Sin A is what? We take the angle here. This is sin A. Sin A is defined as length of the opposite side divided by hypotenuse, that is 15 centimeters divided by 17 centimeters. Centimeters will get cancelled and we get it as 15 by 17. And we can calculate cos A. Cos A is what? Can anybody tell now? Cos A. Cos A is length of the adjacent side, that is AB, and divided by the hypotenuse. Okay, length of the adjacent side length is nothing but AB, that is AB divided by AC, that is cos A. AB is 8 centimeters and AC is 17. Always remember, length of the hypotenuse is going to be longer, it is going to be longer than other two sides. And if you want to find tan A, you can take the ratio of sin A divided by cos A, or you can take it as opposite by adjacent side lengths. Opposite side to A is 15, divided by adjacent side it is 8, 15 by 8. Okay, here we can have another is with respect to angle C. Suppose if they ask, by giving these all values, if they ask what is sin C, then what are the values? Sin C, yes, anybody? What is sin C? It is going to be sin C, it is opposite side to sin C is AB, adjacent side to angle C, it is nothing but BC. Okay, so sin C is nothing but opposite side length divided by the hypotenuse, so that is 8 centimeters by 17. And cos C, if you want, for finding cos C, you have to find the adjacent side length, that is nothing but BC for angle C, that is 15, and divided by the length of the hypotenuse, that is going to be 17. Now if you take the ratio of this, tan C we know, you can directly calculate from the diagram, or you can take the ratio of sin C by cos C. Sin C is 8 by 17 divided by 15 by 17. Here we can cancel this 17 in both numerator and denominator. We get it as 8 by 15. This is tan C. Cot C is nothing but 15 by 8. Okay, and I am telling here cosecant C is nothing but 17 by 8. Okay, similarly secant C is nothing but 17 by 15. If you directly look at the diagram and want to find what is tan C, that is opposite side to angle C divided by the adjacent, that is 8 by 15. That is what we got here, 8 by 15. So from the diagram also we can calculate. Thank you for watching. Please subscribe and share. Thank you very much.